Today I am talking about the theorem continuity of composite functions in the chapter limits and continuity. In this theorem, it is saying that if f is continuous at C and g is continuous at f of C, the decomposition f is continuous at C. Proof. Since f is continuous at C and g is continuous at f of C, then the f is defined at C and the g is defined at f of C. Limit x tends to C, f of x is equal to f of C, and limit y tends to f of C, g of y is equal to g of f of C. Since this g is defined at f of C, decomposition f is defined at C and decomposition f is equal to decomposition f of C. Then choose any epsilon 0 greater than 0. Since limit y tends to f of C, g of y is equal to decomposition f of C corresponding to epsilon 0, then there exists delta 1 greater than 0 such that for all y we get that then we get that 0 is less than modulus of y minus f of C less than delta 1, which implies the modulus of g of y minus decomposition f of C less than epsilon 0. Since this implication is true for all y in the domain of G and hence for all f of x in the range of f, replacing this y by f of x, we get that 0 is less than modulus of f of x minus f of C less than delta 1, which implies decomposition f of x minus decomposition f of C less than epsilon 0. This is the equation number 1. Since limit x tends to C, f of x is equal to f of C corresponding to delta 1, then there exists delta greater than 0 such that for all x in the domain of f, we get that 0 is less than modulus of x minus C less than epsilon 0, less than delta, which implies modulus of f of x minus f of C less than delta 1. This is the equation number 2. By combining these two equations, but we have corresponding to any epsilon 0, then there exists delta greater than 0 such that for all x in the domain of f, we get that 0 less than x minus C less than delta which implies modulus of g of decomposition f of x minus decomposition f of C less than epsilon 0. Therefore, limit x tends to C, decomposition f of x is equal to decomposition f of C. That is, limit x tends to C, decomposition f of x is equal to decomposition C. Since limit x tends to C, decomposition f of x exists and it is equal to decomposition f of C. Decomposition f of C is continuous at x is equal to 6. Hence, proof. Thank you.